So now we are going to consider the reference circle method. Now what is reference circle method? In this reference circle method, from using this, we are going to prove that is law projection of SHM is nothing but the uniform circular motion that we want to prove. Or whenever body is performing a uniform circular motion, then for that the projection of SHM is nothing but your uniform circular motion. So that we want to prove. For that case, we can consider this simple like that. So this is a circle. This is called as a reference circle. Reference circle has an origin. And here I have drawn a Cartesian coordinate axis system, x and y axis. And here we have taken y-axis, the diameter along y-axis is to be taken as a reference diameter. Now what I am going to consider, I am going to place a rod. So let's consider this OA is the rod which is kept in this reference circle such that which is making certain angle theta with the x-axis. And if I am going to incident a light, so this parallel arrow indicates the incident light. So here the incident light is incident on this rod, so that of this rod I am getting a shadow along the reference diameter along the y-axis. So OA is the length of the rod and shadow of that rod I am getting along the y, which is nothing but OA dash. Now we have to prove that the projection of this SHM is nothing but, now whenever we are observing this shadow is moving up and down about the origin, about the mean position. So whenever light is incident continuously on the rod, we are getting a shadow along the reference diameter along the y-axis, and it is to be found that whatever this shadow OO dash, this shadow is moving up and down about the mean position as it is. And whenever there is a motion up and down, that type of motion is nothing but the. So you have to prove that. That is, projection of rod is showing you a linear simple harmonic motion. That we have to prove from this reference circle. So now, what I am going to do that here, I can consider here as a reference circle. This reference circle has these two axes. So these two axes I can draw it here as an x-axis and y-axis. This axis will be drawn along this point. Then I can say that O is the origin here, and I can show here this E point is on the positive x-axis, F is along positive y-axis, T is along negative x-axis, and H is along negative y-axis. So now I can say that phase angle for E is 0, phase angle for F is 90 because the particle is moving along the circumference from E point to F point. So it will be traveling an angle, this angle is nothing but 90 degrees. So this F, phase angle of this F point is 90. Phase angle of G point is 180. Phase angle of H point is nothing but 270. And again phase angle of E point is nothing but 270. So this is the rotation. Okay. Now what I will say that initially your particle is at point PO, making certain angle alpha with the x-axis. Then furthermore, this particle from position P0 moves to point P along the circumference with angular velocity omega. Therefore, this radius vector OP will stress a certain angle. That certain angle I can call it as theta. This value of theta can be written as a omega t from the definition of angular velocity. Angular velocity is defined as angular displacement per unit time. And when particle is moving from P0 to P, its angular displacement is theta in time interval t. Therefore, your theta value is nothing but omega. So that value I have written. Now, when this particle reaches to P point, same here, OA is the rod and here OP is nothing but the radius vector of that P point. So from P point, it will give us a projection along the reference diameter. And that projection point along the y-axis is to be called as a OM. So this OM is the projection of particle P along the reference diameter. So this distance is along the y-axis. So this distance I can denote by letter as a y. Now, as this angle you have given here, this total angle is nothing but theta plus alpha. But theta value is what? Omega t. So now this angle value is also equal to nothing but omega t plus alpha. Why? Because your OE and MP, they are parallel. And this OP will represent a transverse. And now this theta plus alpha and this angle, they are the opposite angles. Opposite angles along a transverse line is always equal in measurement. Therefore, this angle measurement is equal to theta plus alpha. Your theta value is nothing but omega t. So this value will be coming as a omega t plus. And now we can find out here this projection of your particle at point P. This projection of a particle P along the reference axis is nothing but OM. So this is, I am going to call it as a projection of a displacement. So projection of displacement will be given by length OM. Projection of a displacement is nothing but OM. So now I have to find out this value of OM. OM will indicate projection of displacement. So I can consider a triangle OMP. In that triangle, I can write down sine of omega t plus alpha. So see here triangle OMP. In that I want to write sine of omega t plus alpha. So sine angle means opposite side of theta. Opposite of omega t plus alpha is nothing but OM. Divided by hypotenuse. Hypotenuse is nothing but OP. OP will be indicating what? Position vector of your particle at point P. So what I am writing, sine omega t plus alpha is equal to opposite side is OM. This is omega t plus alpha. Opposite to that side is OM divided by hypotenuse is OP. Therefore, what I write? OM is equal to OP sine of omega t plus alpha. Your OM is along which axis? Y-axis. So it will give us the intercept along y-axis. So I can write down it as a y. Is equal to OP. OP is nothing but the position vector. Position vector is represented by R sine omega t plus. So see here, this projection along reference diameter, this equation is same as that of your equation of a displacement along the when particle is performing. Only the thing is what? Here projection is along y-axis. Therefore, I am getting this y is equal to. If projection is along x-axis, I will get it x is equal to. But either it is x or y, it is nothing but the displacement. So from this equation, I am getting that your projection of particle along any reference circle when particle is performing uniform circular motion is nothing but the, right? Same thing I can prove for the projection of velocity. Now when I am going to consider about projection of velocity, so I can say here second part as a projection of velocity. Now for this projection of velocity, again I am going to draw the reference circle. So this is my reference circle. O is the center. From that I can draw this coordinate axis as your x-axis, as your y-axis. Here in the previous diagram we have seen that the position vector OP is making certain angle which is nothing but omega t plus. Now when your particle will reach to point P, at that time the instantaneous velocity of this particle P will be given by a tangent. So this tangent will represent a velocity. And already we have seen that in uniform circular motion velocity is equal to v is equal to r. So magnitude of velocity is r. And the direction of velocity at point P will be given by the tangent. And the projection of this P point along the y-axis is nothing but OM. So now what I did, this is nothing but your velocity vector. For this velocity vector, I can draw one more parallel vector here. And now I can complete here this parallelogram. Right? So now what I am getting? This part is nothing but the projection of velocity. So here I am getting this part is nothing but the projection of velocity. So this I can say, suppose I am calling as a M dash is nothing but the projection of velocity. And now what is the thing? This is nothing but angle omega t plus alpha. So by symmetry, this angle is also equal to that is nothing but your omega t plus alpha. Now for this triangle, I can say that triangle this M dash N, M dash N. For this triangle, this projection of velocity vector. Projection of velocity vector is along M dash. This is your velocity vector. From this velocity vector, I have drawn the projection. Projection is along what? M dash. The projection of velocity is nothing but along M dash. Now this M dash, to find out this value of M dash, I have to find out the cos angle. Because you are in the triangle M dash N, your angle is nothing but omega t plus alpha. In that, I can write for cos of omega t plus alpha, which is equal to adjacent side. This is your adjacent side. So your adjacent side is nothing but M dash upon hypotenuse. Hypotenuse is nothing but your Mn. So Mn is nothing but your hypotenuse. So your Mn hypotenuse is nothing but parallel to velocity. And your velocity is nothing but your hypotenuse. Means your Mn, what I can say that M dash can be written as Mn cos of omega t plus alpha. As it is omega t plus alpha, so I can say that here Mn is this side, is parallel to V, velocity vector. Velocity vector is equal to R omega. Means what I will say that M dash, instead of M dash, I can write down this M dash is equal to nothing but your R omega cos of omega t plus. But your M dash will represent what? Projection of velocity. It is parallel to velocity vector. There is nothing to do projection of velocity vector. along the y-axis means what I say that this m dash I can write down as a velocity along y. So see that this is nothing but I am getting the velocity same as that of velocity of a particle performing SHM. And now from this I can now find out the acceleration. So your third part is nothing but the projection of acceleration. Projection of acceleration. Now what is velocity you are getting? Vy is equal to r omega cos of omega t plus alpha. Therefore acceleration, which is nothing but dy by dt of vy, which can be written as ddt of vy is r omega cos of omega t plus alpha. So differentiation comes as a r omega inside the bracket minus omega sin omega t plus alpha, which is equal to minus r omega square sin of omega t plus alpha. That is nothing but your acceleration. So this acceleration can be written as acceleration is equal to minus, here I can say that r sin omega t plus alpha is nothing but your work. So what I can say that y omega. So this is nothing but your acceleration, right? And in this manner, now we have proved that is whenever your particle is performing uniform circular motion, at that time projection of UCM along any diameter is always an SHM. Because whatever this projection we have drawn, in that case your particle is performing uniform circular motion. So projection of UCM is always an simple harmonic motion. So in that manner you can prove this equation. Clear? Any doubt here? And now we can go for our next topic, which is nothing but as your phase in SHM. So this phase in SHM point is very simple. Just you have to concentrate it from your diagramical construction. So whatever the topic we have just now seen, that is projection of UCM is always an SHM. Depending on that, there is a 3-mark question. Show that projection of UCM is always an SHM. So you have to show with the help of diagram of projection of displacement, diagram of projection of velocity. From that you have to do that. Okay, fine. Now we will switch over to your next topic, that is phase in SHM. Now, what is the meaning of this phase as a word? When particle is performing SHM, SHM means what? Particle is moving to and fro along a straight line, and this motion will get repeated after a certain interval of time. So when that particle is performing your to and fro motion, like this manner, when particle is performing to and fro motion about its mean position, so at that time, at any time instant, where that particle is located, that will be given by a certain angle. That angle is to be called as a phase of. So what that phase angle indicates? Phase angle gives us a state of the particle, where that particle is present. So state of particle will be explained by a physical quantity, which is to be called as a phase of SHM. Now this phase of SHM we can understand in better manner if we draw a reference circle. So in the previous topic we have seen, this is our reference circle. In that reference circle, I can draw these two coordinate axes, your x-axis and your y-axis. And now I can say that here, as a when your particle is at E point, at that time I can say that particle is along the axis, horizontal axis. So motion has been started from horizontal axis. So at E point, I can say that your phase angle alpha is equal to 0 degree, initial phase angle. When your particle is moving from E to y axis, that is at F point. So E to F means corresponding angular displacement is 90 degrees. So at F point, your phase angle is nothing but 90 degrees. When it will move from F to G, now here. So see that now, from E to G, complete phase angle is nothing but the pi angle. That is 180 degrees, or I can say pi. That is at what point? G point. And when it will move from G to H, means this angle is nothing but 270. So I can say that at H point, your reference angle is nothing but 270 degree. That 270 degree means what I can say that in the language of pi? It is nothing but your d pi. And when again it will come back to E point, at that time your total angle will become as a 2 pi. So again at E, your phase angle is nothing but 2 pi. Means what? Motion is started from E point when phase angle is 0. That motion will get completed again at angle 2 pi. Means again from 2 pi, your motion will get repeated. So after each 2 pi angle, the motion of the particle will get repeated. And that motion, the projection of that UCR is nothing but the SHM which lie along this line. Clear? Now, we can consider, so at this E, F, G and H, at this point I have explained your complete phase angle. Now we can consider some special cases of this phase angle. Now what that special cases are there? So just concentrate that special cases, whatever you will get it, that is nothing but, we can say here, when your particle is at mean position. So your particle is at a mean position. Mean position means in the reference circle, your particle is at O point. So your particle is at O point. Now from this O point, when particle is moving towards the positivity, towards the positive point, positive displacement. So when particle is moving from mean position to the positive axis, at that time there is a beginning of first oscillation. And whenever there is a beginning of first oscillation, so at that time I can say that your phase angle is nothing but as your, I can say as a phase angle alpha. This phase angle, I can call it as phi is equal to 0 degree. And now this particle is moving towards the positive axis, means the particle has just started its oscillation. So particle has started its oscillation. So I can say that it is the beginning of first oscillation, and I can say that might be it is the beginning of second oscillation, because just now we have seen that is when particle motion will get repeated after angle of 2 pi. So when particle is moving towards the from mean position transition to positivity means either there is a beginning of first oscillation or there is a beginning of second oscillation. Right? Then, if your phase angle, so if phase angle is 0 degree, means particle has in the first oscillation or there is a beginning of, first oscillation or second oscillation. But if your phase angle phi is equal to pi by 2 or 90 degree, I can say that. If your phase angle is pi by 2 or 90 degree, means what we can say that extreme positive here. Here is the extreme positivity. Extreme positivity means I can say that there is a beginning of second oscillation. So beginning of second oscillation, therefore the phase angle alpha can be nothing but beginning of second oscillation means 2 pi plus pi by 2. Means here the phase angle is nothing but pi by 2. Is nothing but that particular phase angle. Means for second oscillation, this first oscillation 2 pi plus pi by 2 means one oscillation has been completed, and now your particle is entering into the second oscillation. So now your particle is performing a second oscillation if the phase angle is nothing but 90. Clear? Now, if I am saying that, so if your phase angle is 90 degree, then particle has completed the first oscillation and the particle will be get entered into the second oscillation. Then I can say that the next condition as, so first oscillation is complete. Oscillation is complete here, and starting of second oscillation. Now, if your phi is equal to pi. Now, if your phi is equal to pi, means what I can say that here the phase angle can be written as, now pi means what? It will come to the G point. It will come to the G point means total phase angle will become 2 pi plus pi. 2 pi plus pi means what? Again, the particle is in the second oscillation. Is it right? Because it has not completed the completion. So particle is in the second oscillation and its phase angle, here I can say that its phase angle is nothing but 3 pi. If now your phase angle phi is equal to nothing but 3 pi by 2, means here at H point, at H. At that time what we can say that phase angle, this phase angle can be written as 2 pi plus 3 pi by 2, which is equal to nothing but 7 pi by 2. Here. Means what? Again the particle is in the second oscillation itself, but particle is moving towards what? Negative extreme. So particle is moving towards the negative extreme. Clear? So in that manner, we can describe the different phases. Okay, now when it will move from H to E, means your phase angle is what? Here I am getting as a, the phase angle is nothing but the 2 pi plus 2 pi means 4 pi. So 4 pi means what? 2 oscillations are completed. The particle has completed the 2 oscillations. Is it right? So in that manner, we can explain the phase of oscillation. Okay, that you will get more clear idea if I take one example. So let us take one example which is given in your textbook. That example is given as a, that is describe the state of oscillation of a particle if the phase angle is, you have given phase angle is equal to 110 degree. 1110 degree. So now this 1110 degree I can write down 3 into 360 like this plus 3 into 360. How much it is? 0, 8, 1080. So how much is remaining? 32. Right? Means now what I can say that this is nothing but 3. 360 means 2 pi. Plus 3 into 2 pi means 3 oscillations are completed and particle is entering into the fourth oscillation. So particle is entering into the fourth oscillation by angle of 30 degree. As it is entering into the fourth oscillation, so particle is in fourth oscillation. Particle has completed 3 oscillation. Why? Because angle I am getting 3 multiplied by 2 pi plus 30. So 3 times 2 pi angle has been completed, means 3 oscillations are complete, plus 30 angle means particle is in the fourth oscillation. And when that particle is in the fourth oscillation, so I can say that here I can express its state as a sine 30, which is equal to a. Means your particle is in the fourth oscillation and now your particle is at a distance of a by 2 from the mean position, means it is moving towards the positive. Now might be the question comes in your mind, that is your phase angle. In this value is of what? Omega t plus I. Right? And how I have calculated this might be question comes in your mind. You have x is equal to a sine omega t plus alpha. Is it right? So x is equal to a sine omega t plus alpha is how much? 3 multiplied by 2 pi plus 30 degree, which can be written as a into sine 30. And sine 30 is nothing but half, means what I am getting? Displacement of that particle is nothing but a by 2. Means particle has completed 3 oscillation, it is entering into the fourth oscillation, and while entering in the fourth oscillation, that particle is at a distance of a by 2 from the mean position, means that particle is moving towards the positive. Clear? So like that manner, you can solve the state of the particle. Is it right? So in that manner, you can complete your all the questions regarding the state of. Okay, I will take one more example. Suppose अगर मैंने यहाँ पे कुछ तो भी ऐसे लिया 1400. अगर मैंने 1400 एंगल लिया, then at that time what happens? See here, 1400, इसका मतलब अगर मैंने इसको 3 मल्टीप्लाइड बाई 360 किया तो 3 into 360 means it is 1080. तो वो 400 में से माइनस करेंगे तो what I am getting, it is 320. Right? Your angle is approximately 320. Your angle is 320. यहाँ पे आपका एंगल हो गया 320. ऑलरेडी पार्टिकल ने कितने ऑसिलेशन कंप्लीट किए? 3 और फोर्थ ऑसिलेशन में एंटर हो गया बाय मेकिंग हाउ मच एंगल? 340. 340 मींस देखो यहाँ से यहाँ तक 90, यहाँ तक 180, यहाँ तक 270 और अभी 270 टू 360 के बीच में मींस आपका पार्टिकल यहाँ कहाँ हो गया? 270 के आगे कितना? 320 है ना, तो 320 में से 270 गया मींस यहाँ पे 50 डिग्री आ गया. इसका मतलब क्या है? आपका पार्टिकल हैज कंप्लीटेड 3 ऑसिलेशन एंड नाउ इट इज इन द फोर्थ क्वाड्रेंट. एंड तो फिर यहाँ पे आपकी वैल्यू क्या आ गई? ऐसे 320, तो यहाँ पे लिखेंगे 320, is it right? And using that we can solve. तो यहाँ पे हम लोग ऐसा भी लिख सकते हैं इसको. It is 2 pi minus 40. So sin of 2 pi minus theta can be written as sin of theta. वो क्या आएगा sin of 40. Sin of 40 के लिए क्यों? Because they are moving towards the positive extreme. So वो sin of 40, so A into sin of 40, that is the displacement of the. So like that manner, you can solve the number of examples in that indicating the phase of oscillation. Fine. So now I am going to stop today's lecture for phase of oscillation. Whatever angle you have given in phase of oscillation, that angle you have to solve. What you have to remember? One oscillation means 2 pi. So whatever angle you have given, from that you can take out multiple of 2 pi. जितने multiple of 2 pi होंगे उतने oscillation complete है. फिर बचा हुआ angle means that is entering into the next oscillation, and then you can find out the state of matter. Clear? Fine. So now I am going to stop my lecture, today's lecture. Next time we can see the next one.